Hello and welcome. This is going to be our lecture video for October 30th. Let's go ahead and get started, get those notes out, get ready to take notes. Our goal for today is to be able to solve challenging equations and solve proportions by cross multiplying. We're really going to focus on proportions today, and that's because proportions are really common in the real world because it keeps this thing called a ratio constant on both sides. So a ratio is whenever two numbers are connected by another word would maybe be a constant rate or a constant fraction. The amount per each stays the same. Okay, so this would be our most basic type of proportion here. This was actually number 4 on the challenging equations worksheet I gave you guys last class. But for this one, you almost don't need to cross multiply. For this one, we can just get rid of what's being done to the variable because we only have the one variable. We can just multiply both sides by 15. So copy this down and show that we're going to multiply both sides by 15. On this side, it's going to cancel. And over here, when we multiply a number to a fraction, we multiply to the top of that fraction. So now I get 15 over 15 equals r. And 15 divided by 15 is 1. So 1 equals r, or flip it around, r equals 1. All right. Now it's getting a little bit more challenging. We got this minus 7 with the variable. Now it's time to start cross multiplying. So here's how we cross multiply. First, copy this down. Next, we're going to circle parts of the fraction that are diagonal from one another. And there has to be the equal sign in between. All right, now what we circled, we're going to multiply. But because this was p minus 7, this is going to stay in a set of parentheses when we multiply the 9 to it, so that the 9 gets distributed to both the p and the minus 7. So this is going to become 9 times p minus 7 on one side of the equal sign, and on the other is going to be 7 times 7. All right, so whatever got circled got multiplied, and then they're separated by an equal sign. Now let's finish solving this. I can distribute in the 9 here. 7 times 7, that can become a 49. So in the next step, this is going to look like 9p minus 63 equals 49. And now we've got a two-step equation. I'll add 63 to both sides. I get 9p equals 112. That is not divisible by 9, but I can still bring the 9 over to the other side. Divide both sides by 9. All right, this says p equals 112 over 9. That's not divisible by 3 either, so this would actually, we'll leave that as that improper fraction, 112 ninths. You could turn it into a mixed number, but I like improper fractions like that. All right. Here now we've got two variables, but again, fraction equals a fraction. If you have fraction equals a fraction with no addition outside of it, you can do cross multiplying. All right, there's a lot of things that can block cross multiplying, but when you get this exact setup of fraction equals a fraction, you can do the circling and then rewrite a new equation. So it doesn't matter which goes on the left, which goes on the right. I'll do the blue circle on the left, 8 times a plus 6, and the green circle on the right, 9 times a plus 3. And now it's an equation without fractions. We can just follow our normal steps to solving this. So distribute that 8, distribute this 9. I'll get 8a, and then this 8 has to multiply the 6 as well, so plus 48 equals 9a plus 27. I've got variables on both sides, so I want to get them to the same side. I'm going to move the smaller one, which is the 8a, so I'll subtract 8a from both sides. Now I've got 48 equals a plus 27. I've got constants on both sides. I'll subtract the 27 to move it away from the variable, and I get 21 equals a, or a equals 21. All right. And plug it back into double check. On the top here, we'd get a 24. On the bottom, we'd get a 27. Divide the top and the bottom by 3, we get 8 over 9 equals 8 over 9. It does balance. All right, another one for you to copy down. Maybe try this, pause the video and try this one first. Okay, so I've got fraction equals a fraction with no addition or anything else outside of it. So I can circle parts of the fraction that are diagonal, multiply them. So 2 times 5n on one side and 7 times n minus 3 on the other. Simplify and distribute. Get 10n equals 7n minus 21. We'll move the n's to one side, so now we've got 3n equals negative 21. Got to leave that negative behind, even when we move the 7n over. And now this 3 is multiplying the n, so I get rid of it by dividing it from both sides. And I get n equals negative 7. All right, do a quick double check. It works out. All right, now I've got a couple of word problems where we're gonna have to set them up and then we'll solve them using this new technique. So Chef Rita is cooking for a Sunday brunch. She knows that 22 pancakes can feed 8 people. She's wondering how many people can she feed with 55 pancakes. She assumes each person eats the same number of pancakes. So this is a ratio that 22 pancakes feeds 8 people. Take your ratios and turn them into fractions. So we're going to say 8 over 22. So now we've turned this into a ratio. And that ratio is going to be the people to pancakes ratio. All right, and this fraction is never going to change. I can make the top and the bottom bigger by the same amount. Like I can multiply the top by 2 and multiply the bottom by 2. And that would just show that 16 people will eat 44 pancakes. All right, so as long as I keep this fraction the same, the ratio of people to pancakes is going to stay the same. All right, so we're going to set this equal to x for the unknown number of people is equal to 55 pancakes. So still people on top, still pancakes on the bottom. All right, and now we've got an equation that we can solve. I'm just going to multiply 55 to both sides. And I'll get 55 times 8 over 22 equals x. After the divide by 55 and the times 55 cancel out. And plug this whole thing into your calculator. Let's see, I could divide the top and the bottom by 11. And then I get 40 divided by 2 is 20. So x equals 20. But we need to give it the unit. How many people, so 20 people, can be fed by 55 pancakes? And that is your final answer. All right, let's try another word problem. So Teresa is maintaining a campfire. She can keep the fire burning for 4 hours with 6 logs. So turn that immediately into a fraction. 4 hours equals 6 logs. So we'll always do hours over logs. She wants to know how many logs, so an unknown number of logs, is needed to keep the fire burning for 18 hours. Again, hours is on top, logs is on bottom. Easiest way to solve this would maybe be to do some cross multiplying. And now I've got 4x equals, what would that be, 108. Divide both sides by 4. And we get x equals 27. Got to give it a unit, so it's 27 hours. Or no, wait, I picked the wrong unit. 27 logs keeps the fire burning for 18 hours. I had to go back and reread the question. She wants to know how many logs. Oh, and they suggest the variable y. I used x. We could have used a y throughout. Also, I think the last one suggested the variable p. Again, I used x. Here, I'll try to do it better with our very last problem. Liliana used 4 dark power crystals to raise 14 zombie soldiers. She wants to know how many zombie soldiers, Z, she can raise with 10 dark power crystals. So 4 dark power crystals equals 14 zombies. So 4 over 14. So I'm always going to do crystals on top and zombies on the bottom. Equals, she wants to know how many zombie soldiers, so I'll use Z this time for zombie soldiers, she can raise with 10 dark power crystals. All right, let's do some cross multiplying. I'll draw this circles better. Try to do it all quick. Now I've got 4Z equals 140 after I'm just multiplying those in my head. Divide both sides by 4. And we get Z equals 140 divided by 4 is going to be 35. And then reread the problem. So how many zombie soldiers? So it's 35 zombies. Alright, can be raised with 10 power crystals. Alright, which makes sense because if 4 can raise 14, then 2 could have raised 7. And we've got 5 sets of 2 here, so 5 times 7. That's another way we could have gotten 35. Okay, I'll embed a few more questions here, but that's that for this lecture video. Have a good rest of your day.